Hello, everyone. I hope you all are doing well. Thank you for joining in. My name is Venkat Kamath. I'm a part of platform engineering in transaction banking at Goldman Sachs. First of all, thank you to the Kong team for having me here as part of the Kong Summit. I'm super excited to share our experience and journey with Kong and share some of the lessons learned. Let's get started. So to set the business context, transaction banking is a new offering from Goldman Sachs, which provides a digital platform to our corporations to help manage their cash, their liquidity, and process payments. Our mission is very simple: provide a global transaction banking platform that is nimble, secure, and easy for our clients to use. The key differentiators are the platform is cloud native. In other words, the platform is built from ground up, and it makes it easy for us to really deliver features to our clients at time to market. The platform is designed to be highly resilient and always available 24/7. One of the key areas that we focus is, the focus on building first-class APIs. So we want to make sure that we have an API first mindset and expose all our functionalities and capabilities to our clients through very rich APIs. We at Transaction Banking take a lot of pride in building and designing these APIs. So with that special focus on APIs, let's dive into the topic of API gateway. So let's discuss the problem statement. So when we started designing our digital platform, we embraced microservices architecture. And one of the key problems we wanted to solve is how do we enable connectivity to these microservices from an external client? So we're looking to stand up a foundational component that would basically process all the north to south API traffic from the clients at the edge, and then make sure that it meets and satisfies the following non-functional requirements. The gateway needs to have a very strong security posture. In other words, it needs to have all the right security controls in the form of client authentication, authorization, the ability to inspect messages, and so on. The API gateway should have a very simple architecture. It should have an automated process of building and provisioning it. And it needs to integrate with all the operational tools so that our SRE team can get real-time insights into the behavior of the platform. The gateway should also be highly resilient and should not have a single point of failure. And at the same time, it should always be high performance, such that with increase in API load, the gateway should be able to horizontally scale without any impact to our SLAs. Last but not the least, the API gateway should support multi-platform. In other words, it should support both cloud and on-prem platforms. So during our evaluation, we found that the Kong API gateway meets all these requirements. Hence, we made a decision to actually go with Kong as a strategic API gateway for a digital platform in the cloud. Okay, so let's discuss about how Kong really implements some of these cross-cutting concerns. So traffic shaping. So essentially, you would have a number of microservices in the cloud, and you really don't want clients to be exposed on how these services are organized. Ideally, you want to provide one single unified interface to clients, and then have some rules which will basically decide when the incoming request, how do we actually match that incoming request to one of the microservices. And Kong provides a great deal of flexibility in how you really do that matching using host names, API methods, and API paths. WAF represents the Web Application Firewall. It's a very specialized software which prevents the actual API workloads from a number of application layer attacks, such as cross-site scripting, SQL injection. So Kong provides seamless integration to a number of WAF products through the plugin. Now, no topic on API is complete without speaking about authentication. And we see that there are two popular styles of authentication. One is mTLS based, and the other is OAuth2 based. So we have a slide where we dedicate and talk in more detail about mTLS. For now, let's discuss about OAuth2. So this is typically authentication mechanism that's very popular for API requests that are coming from the browser. And typically you will have a JWT sign token, bearer token, and Kong provides OIDC plugin, which allows you to validate that token and really integrate with an IDP. I must admit that this is probably one of those plugins which has overwhelming number of configurations, which also talks about the flexibility. But I think the Kong team was really instrumental in helping us guide the various config and help us really integrate with the IDP that was interest to us. Speaking of authorization is also important, where it's always good to make a security control where in the incoming request, does the client have the permissions to basically make a call to a particular endpoint? And you can think of different models where you could have authorization based on products, or you could have authorization within a product. You could say that, does the client have the authorization to to make either a call to read-only APIs, or could be an update APIs, right? Request validation, another key security control where we should be able to inspect all the incoming API payloads and make sure that it adheres to the contract that we define. For example, we want to ensure that the number of cookies, the number of headers, the query parameters all adhere to the syntax validation that's been defined in the API spec. The same applies to the request body, where we want to ensure that the request body also adheres and conforms to the JSON schema that has been defined. And Kong provides a plugin to basically do that request validation. In terms of rate limiting, it's important to for an API gateway to throttle the number of client requests. And the idea is to ensure that if there's one client which is actually creating some peak burst traffic, we don't want that client to actually have a stability impact on the infrastructure and impact other clients. So Kong provides a rate limiting advanced plugin, which gives a lot of flexibility around how we configure rate limiting windows. And also it provides you, HTTP header responses so that client can gracefully deal with rate limiting errors. Okay. So let's, switch gears and spend some time on our connectivity architecture pattern. As I said, as enterprises build new businesses in the cloud, we'll have to live with the world where you have a number of API new workloads that are running in the cloud, and there are existing workloads in your on-prem data center. And we need to have a pattern where we are able to establish communication between these two workloads. And typically you would want to use more real-time synchronous communication, more REST-style communication. So Kong plays a very critical role by being an ingress controller for all those API workloads, both from when they're connecting from on-prem to your cloud and vice versa. Okay. Now let's deep dive into the Kong deployment architecture. So as I said, it's important for Kong to really integrate with the native services that the cloud offer provides. In our case, Kong integrates with a number of AWS services. To name a few, we like the idea of immutable infra. So Kong is packaged as a Docker container, and you have the option of either using ECS or EKS in AWS as an orchestration engine. Kong, all the secrets that are relevant to Kong, like database passwords, or it could be a private key of your certificates, that are all stored in Secrets Manager. Kong also integrates with PCA for signing of some certificates, and we'll talk a bit more detail in the mTLS slide. Certificate, the credential rotation is a good practice, so we ensure that all our credentials, like database passwords and certs, are rotated at a frequent time, and that is enabled using the rotation lambda that's attached to a secret. Network load balancer, we basically friend Kong nodes by NLB and use a TCP based load balancer to actually sprinkle the request between different Kong instances that are deployed in different availability zones for the purpose of resiliency. We ingest all the CloudWatch, the Kong logs and the Kong metrics into CloudWatch, which allows us to create CloudWatch metrics and alarms. We use Route 53 for accessing the Kong DNS. We use KMS for encrypting any data that Kong stores on disk, or for any Kong config that's stored in the database. VPC endpoint is a key construct here, where Kong would need to connect to the upstream microservices, which are all deployed in different AWS accounts, and VPC endpoint enables the connectivity between Kong and the upstreams. RDS is basically the, we use the database offering to store all the Kong config. Okay, interesting. So mTLS. How do we, so one of the things we wanted to ensure is for our system-to-system communication, we think mTLS is a good choice because it doesn't allow, there's no bearer token that exchange between the client and the server during the handshake, and the magic of TLS does the trick. So to get mTLS to work in a first implementation, we had to really customize the Nginx template to inject some of the Nginx specific directives to get the TLS setup, mTLS setup working. So essentially, we need to create we have a PCA, which we allow to create the certificates. And it's important to really understand that that there are two distinct mTLS handshakes here. One between the client and Kong, that's one handshake. And then we also ensure that there is a mTLS handshake between the Kong and the upstream service. And the idea is to ensure that we have end-to-end mTLS connection for the API flow. So we create two distinct PCAs, one PCA for signing the certificates and providing it to the clients, and the other PCA to actually sign the certificates and give it to Kong when it actually does a handshake with the upstream. So this Nginx template obviously has its downsides where it doesn't really map the client context to the concept of consumer, and you can't leverage some of the consumer related benefits of using Kong plugins. So this is where another example of how the Kong team was able to listen to us, get our inputs, and then work with us to build a first-class mTLS template to support mTLS client auth. The third point is around it's important that once you are through with the mTLS handshake, we need to basically pass the common name and the certificate material in the headers, so that the upstream services actually understands who the client is and actually do a digital integrity check on the certificate itself. We thought it would be good to share the experience of how some of the challenges we faced with initially with putting NLB in front of Kong. Essentially, when you get a client request, NLB would forward the request to Kong, and Kong would basically get the NLB's IP as a source IP, and you would really lose track of who the real client IP is. So we had to really tweak some configuration on the NLB to enable proxy protocol support, where it would basically put the actual client IP as part of the proxy header. And then we use the Nginx real IP module to basically read the IP from the proxy header and stick it into one of the HTTP headers, so that the real IP can be used for auditing, compliance, and for troubleshooting purposes. Okay. So speaking about deployment strategies, I think it was important for us to make sure that Kong, we have a good developer experience for our developers. So essentially, there are two distinct stages where developer interacts with Kong. One is when you develop a new microservice, when you deploy a new microservice, you need to register that microservice with Kong, as a service entity. And then once you do that, the second step is to basically register the OpenAPI spec with Kong, so that Kong then can configure the routes and the various plugins using the information that's there in the OpenAPI spec. And we think that that's that automation is important to really make sure that developers have a great experience of onboarding their endpoints onto the Kong. We take infrastructure as code very seriously in the firm. The idea is to make sure that we have an automated way of provisioning the infrastructure, and we really believe in our infrastructure repaving, where we want to on a timely basis we want to really destroy all our infrastructure, create the infrastructure from the scratch, and infrastructure code as a code tools like Ansible and Terraform really helps you to achieve that. Speaking of data and control plane, we see that Kong has, as a proxy server, which acts as a data plane, and then admin server, which acts as a control plane. And we really like that sort of distinction between the two, and separation of runtimes, because ideally we want to ensure that the control plane availability window is minimal. So what we essentially do is we have different Docker images for data plane and control plane, and you only bring up control plane only when we do have to do some provisioning task where we have to update the Kong config, and that really improves and enhances our security posture for Kong. In terms of, as I said in the first, one of our differentiators has been the 24/7 availability. And in order to accomplish that, we have embraced the idea of blue-green deployment, where essentially we have a blue cluster and a green cluster, and one of them acts as a primary and other acts as standby. And when we deploy new changes, we deploy to the standby. We basically, run our canary tests, run our smoke tests, and once we feel that all the validations are successful, then we basically switch the client DNS to point to standby, and then that too becomes the standby. It also provides you a mechanism to roll back seamlessly if you have any issues. Okay. In terms of observability, I think it's important to make sure that we capture all the key metrics from Kong, and provide and convert those metrics into insights that really helps our L3, our SRE, our production support team to look into the these metrics and help troubleshooting, or if there is any abnormal behavior in a system. So Kong provides a number of key information to the logs. Typically, you would see that either the logs have too much of information, which could be noise, or it has too little information, which is not useful. I think Kong gives the flexibility to make sure that we have the optimal amount of information in access logs for us to be able to track all the requests. We also like the JSON response format in request response logs. And one of the key metrics that we are interested in that is the latency, to really find out that for across requests, how much time do we really spend in Kong layer versus how much time do we really spend between round trip to upstream and coming back, and that's the vital information for us. In terms of plugin, I think here was the opportunity for us to really customize an existing plugin where we wanted to make sure we have a control over what headers get logged into our logs. So we basically came up with the concept of allow list for the HTTP headers, and we only log those headers which doesn't have any sensitive information with the logs. As I said before, we use CloudWatch. We ingest all the JSON formatted logs into CloudWatch, and we use CloudWatch log insights, which provides you a powerful JSON style query to actually slice and dice the data. We build a number of CloudWatch dashboards, which gives visibility into how the traffic is performing, and really allows you to slice and dice the various metrics like latency and response codes by client and by service. We also enrich the logs and convert those into metrics and alarms. So in case if you want to get notified when there is a breach of certain number of 401 unauthorized errors, CloudWatch metrics and alarms allows us to do that. So just to summarize, Kong as an API gateway plays a very critical role in the microservice architecture to really act as a mediator between client and the API workloads. I think the nice thing that our security team and compliance team likes is that all the security controls are centralized, and they are all implemented in the central API gateway layer. And really, it takes the some of these cross-cutting concerns. The responsibilities gets shifted from the application development teams into the API layer. Kong is the plugin architecture is extremely extensible, and we had a couple of use cases where we had to really customize the plugin to meet our own the high bar that we set for our own internal security standards. Kong, by design, provides the flexibility to run on-prem and cloud, and it's important because you want to have a consistent implementation of your API gateway security controls, so that we feel very strong about how our security posture is for all the API communication between your cloud and on-prem workloads. Kong also has support for open standards like OAuth 2, integration, open API spec, rate limiting. as well as Zipkin for distributed tracing. And that's really important for engaging developers so that they don't have to learn something vendor specific and they can embrace some of these open standards. So I think to summarize, it's been a great partnership with Kong. They've really helped us build a very secure API gateway for the rollout of our digital platform. In case if you're interested to know more about what Goldman Sachs does in transaction tracking space, feel free to follow us on the LinkedIn showcase page. Thanks for listening in. Have a good day, and I'm open for Q&A.